Hello guys, welcome back to ChemOrgChem. In this NEET Chemistry 360 series, we are exploring the solution for previous year NEET exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the question from NEET 2024. So according to this question, we should find out the correct option that will undergo SN1 reaction with fastest rate. So here you see there are four options. Let's figure out together which one is the correct option for this question. Before moving that, we should recall SN1 reaction. So SN1 stands for substitution nucleophilic unimolecular. The SN1 reaction is a type of substitution reaction where a nucleophile, something that loves a positive charge species, replaces a leaving group like halide ion such as Cl minus or Br minus on a carbon atom. So this reaction is a two-step reaction. The rate of reaction depends on the concentration of only one reactant, that is concentration of alkyl halide here. So we already know that this reaction undergo by two-step reaction. The initial step is the generation of carbocation, which is the slowest step. The second step, the nucleophilic attack by the carbocation intermediate, which produce this corresponding product. Here, OH minus, that is hydroxide ion, act as a nucleophile. Okay, why do some alkyl halides react faster in SN1 reaction? So that is an interesting question. So the speed or rate of SN1 reaction depends heavily on the stability of carbocations. So here you see, we already know that three types of carbocations such as primary carbocation, secondary carbocation, and tertiary carbocations. So in these three carbocation, when you arrange the stability order, tertiary carbocation is more stable than secondary and primary. Then primary carbocation is one of the least stable carbocation. So based on that, when you arrange the alkyl halides, tertiary alkyl halide that react faster in SN1 reaction, in case of methyl halide, which is one of the least reaction rate in SN1 reaction. So based on that, so now you see the first option. The first option is primary alkyl halide. So according to the first step of SN1 reaction, which produce primary carbocation, in second option, so now you see this one is a secondary alkyl halide. So when it undergo this substrate in SN1 reaction, which produce secondary carbocation, in third option is aromatic halide. So in general, aromatic halide don't involve any SN1 reaction. Anyway, you just see in imaginary way. So if it undergo by SN1 reaction, so that may produce this phenyl carbocation. So this phenyl carbocation is highly unstable species. So why this phenyl carbocation is highly unstable species? So now you see, so here you see, so this is the vacant p orbital, while these green color orbitals are filled p orbital. Since here you see this pi electron resonance stabilized by this ring system. So therefore, this system, I mean this orbital and this vacant p orbital, both are present perpendicular to each other. So therefore, resonance stabilization is not possible in this case. Therefore, this phenyl carbocation is highly unstable species. So based on our question, the carbocation, which is most stablest one, that substrate could undergo fastest SN1 reaction rate. So therefore, so this option may not be a correct option for this question. Now moving on, fourth option. So this one, secondary alkyl halide, when it undergo SN1 reaction, which produce secondary carbocation. So based on this series, so now you see this one is a primary alkyl halide. Therefore, this is definitely may not be a correct option for this question. So the primary carbocation is stabilized by hyperconjugation. So now you see these two options. So second option and fourth option, both are producing secondary carbocation as an intermediate. So when you compare this series, so secondary alkyl halide, which is comparable rate. So therefore, we should find which one is the correct option in these both secondary carbocation intermediate containing alkyl halides. So this secondary carbocation is stabilized by hyperconjugation. In case of this secondary carbocation stabilized by resonance, since now you see this carbon attached with phenyl ring system. Therefore, this positive charge stabilized by this phenyl ring system by resonance. So now you see here the positive charge, that is a carbocation. Now this electron shifted here, resulting that now carbocations comes here, then followed by this electron shifted here. Now positive charge moves here, and this electron shifted here. Now positive charge moves here. In the way, this positive charge, that is carbocation, is stabilized by resonance. So when you compare to the hyperconjugation and resonance, resonance is a dominant force to stabilize the carbocation intermediate. So therefore, the second option may not be a correct option. So the fourth option definitely a correct option for this question. So based on our discussion, the correct option for this question is answer 4. That's it for today's problem. If you found this video helpful, please give it a thumbs up. And don't forget to share it with your friends, and make sure to subscribe and hit the bell icon for notification so you never miss on update from ChemOrgChem. Finally, thanks for watching. Bye bye.